Okay, so in this example, we're going to look at a slightly harder version of similar triangles and how they're used. All right. So as you can see, we've got two triangles which are similar, and we're asked to find the lengths of A and B. Now, in this type of question, your best bet, in my opinion, is to start by flipping the second triangle over. Okay. So if we flip that triangle over, what we end up with is something that looks like this. It doesn't have to be drawn super accurately, but really what we're looking for is to label the sides correctly so that they correspond in the correct way. Okay, so what I've done is I've flipped that, turned that round so that we have the same diagram but in a different way. It looks different. So EF is still 4.5. EG is now on the top, which is A, and FG has switched and been flipped over to be something like that. Now what we can do is we can now connect the corresponding sides together. Okay, and as we've said before, my tip to you is if you're trying to find A, then start with A. So A goes to the ratio of A to 4, so I'm now going to corresponding sides. The EG corresponds with AC. So A goes to 4, and what we're looking for now is that 4.5 goes to 3. This implies, right, if I multiply both sides by 4, that will cancel those out, so I have to multiply this by 4 as well. So what I'll end up with is A is equal to 4.5 over 3 times 4. And when you tap that on your calculator, etc., you end up with 6. Okay, so A has length 6. Do the same for B. Write down, because B is the thing we're trying to find, B goes to 2, and that ratio is the same as 4.5 to 3. And again, what we can do this time is multiply both sides by 2. If we do 2 halves, they cancel out, so we have to do this side by 2 as well. So all we're doing is just rearranging these little formulas, these equations, should I say, and when we get to there, use your calculator, however you want to do it. 2 times 4.5 is 9, 9 divided by 3 is 3. And that's it. You found the length of A, and you found the length of B. Okay? And that's it. So it's a matter of recognizing that you're told that they are similar, and just recognizing that it's a good idea to flip those things over. All right? So the next type of example, I've got one here, is slightly different in the sense of where can you see two triangles? And that's the technique to these. So in this case, what I'd be looking at is not flipping things over or turning them around, whatever, but I would be looking at splitting those two triangles so that I've got a big triangle, which would be ABC, and then put those values on. AC is 6. Now BC obviously is the length 3 plus that length 4.5. So BC is 7.5. Okay? Now, take out the other triangle, which is PQC, and you'll see that PC is 4.5 and QC is 5.1. Now, we've got matching triangles there, if you like. We've got similar triangles. Why? Because the angles are the same. I suppose the assumption that we're making here is that these two are parallel. AB is parallel to PQ. Okay? So when you've got that, you're now back to a level 1 to 4 type question now. You're now back to the place that you started from. All right? Now, the question, part 1, says find PQ. All right? So PQ is the thing I'm trying to find. So I write that down first. PQ goes to 6 just as 4.5 goes to 7.5. And again, if I multiply this side by 6, they cancel out, so I must multiply this by 6 on this side here. Alright, so keeping that balance all the way through. So PQ is 4.5 over 7.5, and I'm going to multiply by that 6. Alright, tap, 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 tap on your calculator. However you want to do it, you end up with 3.6. So PQ is 3.6, and that's that first one done. Alright, okay. Angle ABC, well, to be honest, it's a little bit trivial, so I don't think I'll do that one, really. You can see that what we're saying is we're assuming they are similar because these are parallel, and you can work out the triangle ABC just by doing 180, take away 60, take away 43, and that's it. Alright, that's done.